Welcome back, data enthusiasts, to another thrilling episode of Data with Larry. Today we are diving headfirst into the Kaggle challenge, House Prices Advanced Regression Techniques. This competition is all about predicting sales prices and mastering feature engineering, random forests, and gradient boosting. But there is a twist. We are going to supercharge our analysis with the help of ChatGPT. The competition is called House Prices Advanced Regression Techniques. So here we will predict sales prices and practice feature engineering. You can find the dataset and the competition on the Kaggle website. So let's go to the data. So here you'll find dataset description. We have training CSV, the training set, the test set, data description, txt, that would be the description of the features and the target variable, and the sample submission CSV, that's a submission form for the Kaggle website. Data fields description. So that's what we have over here, and you can download train CSV here. That's right, we are bringing AI into the mix to see how ChatGPT can assist us in tackling this exciting data challenge. Now let's work with the train dataset. You can load it by attaching the file to the GPT-4, and we'll ask to describe the data. And let's see what do I have here. So it's saying, of course, I'll begin by loading the data from the file, and after that it will provide the contents. Let's take a look on the code. It will import pandas, load the data, and display the first few rows with data head. So the dataset we provided appears to be related to the housing data, and that's true. Possibly from the Ames housing dataset, and that's true too. And here the brief overview based on the first few rows: the ID, identifier, the building class, general zoning classification, and etc. Sale condition of sale of the house, and the target variable, the sale price, the properties, sale price in dollars. So there are 81 columns in total, with the last column sale price likely being the target variable. That's true. The other 80 columns provide various features and characteristics of the houses. And it's asking what is our next step, right? So as a next step, we would like to do the EDA, exploration data analysis, and create some visuals. It gives us steps. So it will provide us summary statistics, quick statistics on the numeric features, missing values, statistics, and the visualization of the missing values to understand any gaps in the data. So we'll have understanding of how we'll be cleaning the data afterwards. And the target variable distribution, analyzing the distribution of the sale price column, the target variable. Correlation heat map, the correlation of features with the target variable, and visualization for selected features. So let's take a look on the code. So summary statistic for the numeric columns is described. The summary statistic provides insights into the distribution of the numeric columns in the data set. So there are 40 and 60 entries in the data set. However, some columns have missing values. So we got the data set with the missing values. That's important. The mean provides the average value for each column. You can find it everything here, right, for all the features, numeric features. And STD represents the deviation, the standard deviation, which gives an idea about the spread of the values, minimum, maximum, and so on and so on and so on. Next, the visualization of the missing values to get a better understanding of any gaps in the dataset. So what do we have here? The pool, that's a missing values by feature. So we have some of the features got a lot of them missing values, right? And some of them not. The bar chart displays the number of missing values for each feature in descending order. So features like pool feature have fans have a substantial number of missing values, and the suggestion is the houses and the properties might not have these amenities like pools and fans and so on. And other features also have notable missing values, but no lesser extent. It's essential to address these missing values appropriately, either by imputing on or exclusion before any predictive modeling. So we'll work with the missing values as a next step. And next, let's look at the distribution of our target variable, the sale price. So we want to know it looks like normal, right? But it's skewed. Let's see the code. It's just the plotting of the sales price, and it gives us some insights. The histogram displays this distribution. The distribution of sale price is right skewed, indicating meaning there are some houses with exceptionally high prices compared to majority. We can see it here. Most of the houses have sale prices clustered between 100 and 250. Next, to understand the relationship between the numeric features and the target variable, let's create a correlation heat map. This will give us an idea of which features have the strongest linear relationship with the sale price. Let's take a look on the code. So it uses core, it calculating the correlations, then sorting correlations with sale price in descending order, and plotting the heat map. You can see it. So the top correlation with sale price. So that's a heat map. I believe you know how to work with the heat map, so we'll go next. So the heat map displays the top features that have the strongest linear correlation with sale price. So overall material and finish quality have the highest correlation. Above ground living area in square feet also shows a strong positive correlation. Garage cars and garage area, both these features which relate to the size and capacity of the garage, have significant positive correlations, and some other features have notable positive correlation. Next, let's create some visualizations for a few of these top correlated features against the sale price to further understand the relationship, linear or might be in any other relationship, right? So we are selecting top correlated features that we mentioned before. Here you go, and plotting these features against the sale price with a scatter plot. And the scatter plot provides insights into the relationship between the selected features and the sale price. So here the feature, here is sale price, scatter plot, and what it gives us insights about the correlation, what it shows to us. As the overall quality of the house increases, the sale price also tends to increase. That's about overall quality. The living area, there is a positive correlation between the above ground living area and the sale price, and so on and so on and so on. I won't mention all. These visualizations help in understanding the nature of the relationship between individual features and the target variable. They can also be used to identify potential outliers that might influence predictive model. So next, let's work with the missing values in the data. So I'm giving the prompt clean the data. So cleaning the data typically involves several steps on the nature and quality of the data set. So handling missing values. For features with a significant number of missing values, we can consider dropping them, right? For numerical features, we can consider imputation methods such as filling with the median or mean or any other. For categorical features with the fewer missing values, we can either drop the missing rows or fill them with the more outliers. Outliers based on the scatter plot, there seem to be some outliers, so we consider dropping them to improve model performance. Feature engineering. We might want to create new features or transform existing ones to better capture the underlying patterns. For example, the age of the house and the time of sale could be a relevant feature. Categorical variables, categorical features. So as you know, many machine learning models require numerical input, so we'll use one-hot encoding for that. And numerical features. Scaling ensures that all numerical features have the same scale, which can be important for models like linear regression or SVM. So let's take a look on the code. We are handling missing values here. So dropping features with high missing values. For numerical features, fill missing values with median. It's over here, filling it with the median value. For categorical features, fill missing values with mode over here, and check if there are any remaining missing values. Result is here. All missing values have been addressed, and there are no missing values left in the clean dataset. Next, let's address potential outliers. We identified potential outliers in features during our EDA. To handle these outliers, we can use a common technique, removing values that lie beyond a certain number of standard deviations from the mean. So let's do this. Here we are handling outliers, filtering our outliers based on the standard deviation, and checking the shape of the dataset after dropping the outliers. So after addressing the outliers, we got 1,444 entries from the original 1460 entries rows. This means 16 entries were deemed outliers and removed. Next, we need to do one-hot encoding on the categorical features. So it's asking me, would you like to continue with these steps? Yes, of course. We are moving for the model prediction, so we're going to one-hot encode the categorical features. All right, encoding categorical variables. We'll use one-hot encoding to convert categorical variables into numerical format. One-hot encoding creates binary columns for each category and indicate the presence of the category with a 1 or 0. So it will increase the number of features for our model. And that's for the categorical variables. And for the numeric variables, we will be scaling them. We'll scale numerical features to have a mean of 0 and a standard deviation of 1. So let's take a look on the encoding categorical variables using one-hot encoding. So that's a get Ames. Scaling numeric features, we use sklearn preprocessing, and from sklearn preprocessing we import standard scaler. So here you can find the scaling process, and after this the dataset has been cleaned and processed. For the categorical variables we used one-hot encoding, and for the numeric features we used standard scaler. So it's asking with this clean and processed data we can proceed further with the predictive modeling. And I'm asked to understand the dataset and the target variable more and the dependencies on the features. I'm asking to determine the important factors that drive our target variable sale price and create the visuals. So the GPT-4 are answering me, determining the important factors that influence sale price often involves building a predictive model. So now we're building the predictive model and then extracting feature importance. That's perfect. So it will use random forest. So to do this, like feature importance, it uses random forest or gradient boosted trees, which provides a measure of feature importance. So the plan is building the model, train a random forest regressor on the clean data, extract feature importances after training the model on our trained data, and visualize it. So let's take a look on the code. From ensemble, it imports a random forest regressor, separating features, target variable, and the dataset. Train random forest regressor on our dataset, on the trained dataset, with number of estimators, 100 estimators. Extract feature importances with feature importances, and create a data frame for the importances, sort by importances. So we will got importances data frame and sorted descending order, and after that displaying the top 10 features by importance. So what do we have here? We have the table that shows the top 10 features ranked by the importances, and what are those features? That's overall material and finish quality, background living area in square feet, total square feet of basement area, type 1 finished square feet in the basement, size of the garage in terms of car capacity, first floor square footage, original construction date, lot size in square feet, remodel date. Those are 10 most important features for predicting our sale price. And here are the utilization of these feature importances, just a bar plot. So the bar chart visually presents the top 10 important features influencing sale price, and overall quality stands out as the most significant factor influencing the sale price, and features related to the size and quality of the house. Size and quality of the house also play a crucial role in insights, and that's amazing that ChatGPT-4 can give us insights based on the EDA that we can use in our business needs. And the age and condition of the house represented by year build and remodeling year respectively are also influential factors. So that was a challenge. On the house prices Kaggle challenge. So as a next step, we want to use our model on the test data set and submit our predictions to the Kaggle. So we're loading here the test data set and sample submission file. So we're giving the description, the test CSV, the test set. Our goal is to predict the sale price of each house in the test data set. We got metric, right? The metric is evaluated on root mean squared between the logarithm of the predicted value and the logarithm of the observed sales price. So we need to take logs on our test predictions and the submission file, like how the submission should look like. So here's the plan to generate the submission. Load and preprocess the test data, predict with our trained random forest model, apply log transformation to our prediction. Since the evaluation metric is RMSE between the logarithm of the predicted value and the logarithm of the observed sale price, we'll apply a logarithmic transformation to our predictions before calculating the RMSE and generate the submission file. So loading the test CSV and preprocessing the test data. Here is the code for this. Like, we'll do the same, right? Have like missing values, preprocessing numerical features, ensuring test data has the same columns as training data. So with all these, handling the missing columns, the test data being preprocessed for the prediction of the random forest model, and as a next step, we'll apply the trained random forest model to predict the sale price. That's the easiest thing, right? So we're applying to the encoded test data set our model, and right after this, we're applying logarithmic transformation to the predictions. So right after this, we create the submission file in the specified format using the sample submission CSV as the reference. That's easy. And right after the submission file being created, it's asking, do I want to download it? And yeah, that's our target, right? It's creating the file, and we can download it by clicking on the hyperlink. That's probably it. You can play more with this data set, with the trained data set, asking different questions, asking for insights. Yeah, we can use the code here, but I kind of showed like how it works and how it can be applied on your data set in your business and for your business needs.
But first, let's understand the challenge at hand. In the House Prices Advanced Regression Techniques competition, we're tasked with predicting the prices of residential homes. It's not your average guessing game. We've got 79 explanatory variables that dive deep into every aspect of these homes in Ames, Iowa. In conclusion, ChatGPT has proven to be a valuable ally in our data analysis journey. Its natural language capabilities have streamlined our workflow from data exploration to model tuning. Remember, in the world of data science, every tool at your disposal can make a difference. If you found this video insightful, please give it a thumbs up, subscribe to Data with Larry, and share it with your fellow data enthusiasts. Thanks for joining me on this Kaggle adventure, and stay tuned for more exciting data-driven explorations. This is Larry, signing off.